Hello and welcome to What's New in Aerospace. We have a great show for you today. This is kind of the live chat version. I'm Marty Kelsey. I'm one of the hosts of STEM in 30, a TV show for middle school students produced by the National Air and Space Museum. And today we're going to be talking all about future vehicles used in aviation. We're joined by Nikhil Goel from Uber Elevate and Roger Connor, a curator in the Aeronautics Department at the National Air and Space Museum. Thank you both for joining us today.
Thanks for having us, Marty.
Thank you.
All right, so those of you watching, here's the drill. You guys head down to the comments section on Facebook, put your questions in there, and try to stump our experts today. Whatever you guys want to know about urban air mobility or how we're going to be getting around in the future, put those questions in, and we will try to get as many of them answered as we can today. Nikhil, we're going to start with you. Tell us a little bit about Uber Elevate.
Sure, Marty, I'd love to. So look, Uber's larger mission is to ignite opportunity by setting the world in motion. And a big part of that is helping cities become smarter, better, more efficient places to live. And if you zoom out and look at cities today, about half of the world's population lives in cities. The United Nations projects that number will quickly become about 6 billion people living in cities. That's 2/3 of the world's population living in just 50 megacities around the world. And while cities are getting larger and more dense, people in those cities are spending millions of hours wasted on the road. And at Uber, we think about radically improving urban mobility. To us, that means transportation options that are safer, that are faster, that are more accessible, and that cleanly move both people and things from A to B. And amongst all of the things that we're doing on the ground, we also just a few years ago started thinking about the fact that our cities live in 3 dimensions with skyscrapers, they work in 3 dimensions, and why can't we travel in and around cities in 3 dimensions? And so a small team of us started looking into that problem, and your first thought may be, well, why can't we use helicopters? And that's also where we started. There are 2 big problems with helicopters. First, helicopters are tremendously loud. And that's because the speed at which the rotor on top of a helicopter has to turn to stay in the air is really quite fast, and that generates a lot of noise. And the second is they're incredibly complex. They use fuel burning engines, and they have complex systems within to turn that large rotor. And because of that, they require a lot of maintenance to keep it safe, and all of that maintenance costs a lot of money. And so the end effect is that it's quite expensive to get in and around cities with a helicopter. This is where we started working with a gentleman named Dr. Mark Moore at NASA. Mark has spent his entire life working on a technology called distributed electric propulsion, which is truly fundamental and innovative. DEP for short, distributed electric propulsion, enables an entirely new form of aircraft called eVTOLs. I know that's a mouthful. That's an all-electric vertical takeoff and landing vehicle. And today, what we did was we used all of the Uber data around how people get in and around cities to work with some of the top aerospace manufacturers in the world, names that you've all heard of, like Boeing, Bell, Embraer, as well as some newer companies that have spent over a decade working on this tech. Joby Aviation, which recently got a large round of funding from Toyota. Hyundai, which is one of the leading automobile manufacturers in the world, but is now working with us to also build aircraft, and several others, which are all working towards launching an Uber Air service in Dallas, LA, and Melbourne by 2023, and many more cities in the years ahead. And it's super exciting to have this conversation with the National Air and Space Museum. You know, I look back and I think about such incredible aircraft like the Apollo 11, the Spirit of St. Louis, the Bell X-1 that broke the sound barrier. I really see eVTOLs, and we as the Uber Elevate team see this new fundamental technology as that next frontier in aviation. So super excited to be here today.
Awesome. Well, we've got a lot of questions coming in. Remember, if you're watching, put those questions down in the comments section. We'll try to get to as many of them as we can today. Roger, how does what Uber is trying to do fit in with the history of aviation and innovation in aviation?
Marty, if we go back 120 years, so back to the year 1900, so just even when the car was just first starting to kind of appear around cities, there were a lot of people that when you asked kind of the visionaries to imagine what life was going to be like in the year 2000, a lot of those depictions had what we would call a flying car, some sort of flying aerial vehicle that would allow people to move from rooftop to rooftop. So when the airplane came into being, with the Wright brothers in 1903, a lot of people assumed that would somehow transform into runways on rooftops. Now, at the time of the Wright brothers, that was maybe a realistic idea because airplanes didn't use but a couple hundred feet of landing distance. However, by say 1920, airplanes were starting to use a lot more room. And so the idea of putting a big runway that would stretch across a building roof or something, it really didn't work anymore. Now, at that time, 1920, that's about when the idea of the helicopter really is starting to come into being. And so there are a lot of efforts in the 1920s and 30s to kind of figure out, okay, what might you do with a helicopter in the city to allow people to get around? Well, one of the first things that comes up is the idea of getting people from the center of the city out to these new airports, because you have to put the airport out in the countryside. So if we think about where airports are in relation to cities, they're usually, a dozen, even 20 miles outside of a city. So a lot of the early efforts were kind of around how do you do that. And the first technology that really kind of became practical for moving people in that way was something called the autogyro, which was essentially half plane, half helicopter. And nice idea. It could land and take off in a short distance, but it was very expensive. So President Roosevelt, during the Great Depression, one of the things that they try and do is actually push a program to make a lot of these that would be very affordable. They actually made some prototypes. One of them we have here at the museum, but it had the problem that it was never cheap. They would cost as much as a fancy new house rather than as a new car. During World War II, the same kind of idea happened. That the practical helicopter came into being during World War II, and the people that were making the helicopter, like Igor Sikorsky, they were initially promising everybody that they could make those for the same price as a new car. And so everybody during World War II had this idea that immediately after the war, the skies in the cities were going to be filled with helicopter taxis, helicopter buses, helicopter automobiles. And that idea continued through the 1950s, but same problem. They were too expensive, too difficult for that kind of individual ownership. And so if anybody's familiar with like the Jetsons cartoon that was in the 1960s, where everybody was flying around their own kind of personal air vehicle, part of that was kind of a mocking this idea that had been around for 30 years that, oh yeah, everybody's going to have their own personal vehicle and it's just over the horizon. So it's been a really long road trying to get to transportation. So the ideas that Nikhil is talking about of distributed electric propulsion that does away with the heavy components of the helicopter, so things like gearboxes and tail rotors and transmission systems and heavy power plants, all those things up until just the last several years have made this kind of personal vehicle too expensive to operate in the city. They also tend to be very heavy. So if you think about a landing surface, putting a helipad or something on a roof, you have to have that structure built into that building to make it happen. So it's really difficult. It's not just having an aircraft that works, it's having a whole system of places that they can land and getting people to those places that makes it work. And that's why eVTOL is such an interesting new technology, is because they're now light enough that you can start to put them in places like rooftops and open up the areas that these vehicles can operate.
Awesome. Well, we got people watching from Hudson, Wisconsin, Costa Rica, Detroit, Michigan. If you're watching online, tell us where you're watching from and put those comments down put those questions down in the comments section. We've got a bunch of questions coming in, and I think one that's probably coming in more than once is, when are the flying cars going to get here?
Well, it's a great question, Marty, and the punchline is they're already here, right? So there's over 100 companies around the world who are working on this technology, both really, really large aerospace players as well as small startups. It's maybe unfair to call them startups because they're spending a lot of money and investment to do so, but over 100 companies that are building these flying cars today. And our team personally has seen dozens of them already fly. So they're real, and the science and technology is here today. The big challenge now is actually working hand in hand with the FAA to certify the aircraft and getting them ready for mass production. And so we think that that's going to start happening in just about 3 years. And so a number of companies today are already working with the FAA. on the certification process. In fact, we heard the FAA administrator and the Secretary of Transportation, Ms. Lane Chow, both speak about this over the last couple of months, that there's over 10 companies which are already working closely with the FAA to get those aircraft certified. And we expect that we will have our first commercial operations of some of those aircraft by 2023.
Wow. All right. We've got Brody and Bowen watching from Oregon. They want to say hi. We've also got Mark from Detroit watching. Thank you guys for tuning in. There's a question about, does Uber ever plan to become hypersonic or transcontinental?
Well, look, as I mentioned, our larger mission is to get people from A to B in the most efficient way possible and to make cities better. And so one day, I certainly hope that we can have every form of aviation transportation on our platform. But today, we're focused on urban air mobility. That's where we see a lot of our riders, particularly endure really painful routes on the ground, right? San Francisco to San Jose, or you can imagine, Roger, going from the Smithsonian to Dulles. That's a trip that can take over an hour and a half at the wrong time. Those are the trips that we want to focus on first.
All right, so we've got a bunch of questions coming in about the electric helicopters. And Roger, can you talk a little bit about the difference between a traditional helicopter that we think of and an electric helicopter?
So obviously the electric part is a big deal. So up until now, you have to burn hydrocarbons. You're burning gasoline to make the helicopter go. Now, helicopters are nowhere near as efficient as an airplane. If you want to get from A to B in the air, generally speaking, an airplane is the way to go because it's a very efficient way of moving through the air. The problem, of course, is that the runways that you need to take off and land on, those don't work well in a city. You need a lot of space, not just for the runway, but the approach and landing clearances for them to miss things like buildings and towers and whatnot. And there's noise and all sorts of problems. So airplanes are not good around cities for that reason. And so to have something that moves straight up and down, that requires a lot of inefficiency. So the technology required to do that in a helicopter, you got to burn a lot of gas to do that. So that's not good for the environment. So that's been a big problem in the past. You have to have a really lot of complex mechanical systems. So if you look at, the rotor head on a helicopter, you see a lot of moving push rods and hinges and all sorts of things that are going on in there. And then inside the helicopter, there's these very complex gearboxes, so lots of heavy gears meshing together to make all those parts turn in harmony. And with an electric VTOL, you're taking that whole system and really simplifying it. So you're using batteries, or sometimes you're using a very efficient engine to supply the battery, with additional electricity, and then you distribute that to electric motors. So a lot of these electric VTOLs are really kind of the scaled up hobby drones is what you're doing. You're taking a power source and you're moving out to electric motor and spinning those. And so you don't have those drive shafts and those gears to do that. So those electric motors are a lot more efficient. So those really starting to lighten it. Of course, you're getting away from the emissions to a much greater part. So the improvements that we're now seeing in battery density are starting to make this a lot more practical. Mm-hmm. And so that's one of the really significant pushes. Even 10 years ago, where we are right now would have been very difficult to foresee. So we are in a period of a new aeronautical revolution. I know people that were in the helicopter industry 10 years ago that were becoming very disillusioned because nothing new was happening and the technology was stagnating. And so just in the last 10 years, I've seen people become very excited. As Nikhil has said, there are nearly 200 firms now making aircraft that were not doing that just several years ago. So it's a great time to go into the field of aerospace and work on these really exciting projects because nobody knows exactly where the stuff's going. So if you're creative and smart and clever, there's a lot of opportunities now to go and kind of get into the field and make your name by being smart and clever.
And Roger, I'm so glad you mentioned that, because on Wednesday we'll be talking about careers in aviation, and tomorrow we're going to be talking a little bit about the infrastructure of how we keep everybody safe with what's coming up. And so we've got some questions coming in. I'm going to throw them to you guys as well, but also we'll have that live chat tomorrow. But to follow up with what you were saying, Roger, Genevieve and a couple of other people here want to know about the environmental impact. And if we've talked about how it's going to benefit animals moving around, but also going from burning those hydrocarbons to electricity.
Well, I'm sure Nikhil can speak, particularly things like noise is obviously a big thing. So these aircraft are generally going to be a lot quieter than, say, a helicopter. So a helicopter generates a lot of noise because of the way that the blades interact with the air. But certainly when you're going to all electric, you're now powering off the grid. So if the nation can start to move more towards renewable sources, as long as we're not powering our electric grid, off of dirty hydrocarbons, then we can start to make aerial movement a lot greener.
That's right, Roger. And we talked about this a lot in the early days of Uber Elevate, and we were very firm that it was important to us that these aircraft are all electric from day one. And that's because we expect there to ultimately be thousands of these aircraft flying in and around cities. And if we want to become a major part of the transportation fabric, it's really important that they be all electric. And the world's already moving that way towards increasingly renewable forms of energy for transportation. We've seen that in the automobile sector. I think we're going to see the same in the aircraft sector. And the other great point you brought up was noise, Roger. As I mentioned earlier, helicopters are tremendously loud. These aircraft will be over 100 times quieter than helicopters when they take off and land. And importantly, they'll be almost silent when they're flying overhead, because with a helicopter, of course, you've got to spin the large rotor to stay in the air the entire time. With one of these eVTOLs, you really only need the lift power when you're taking off, and then you're able to use the wing for forward flight like a normal airplane. And that allows us to be a lot quieter when we're flying over important parts of the city.
Awesome. All right. Well, we've got people watching from all across the country. We've got Seattle, Spokane in Washington, Fredericksburg, Virginia, Quantico, Rocheville. I've got to pronounce that correctly because they asked me to make sure I pronounce it correctly. Indiana, Louisiana, Farmington, Overland Park, Kansas, Priceville, Alabama, Brighton, Michigan, Goodrich, Michigan, San Francisco, Chambersburg, Myrtle Beach, Miami, and Belmar, New Jersey. Thank you all for tuning in. We appreciate it. Keep sending those questions in. We've got some great questions. How does the speed of one of these eVTOLs compare to a traditional helicopter?
Significantly faster, at least, ultimately significantly faster, especially when you compare it to a car, right? These are going at about 150 to 200 miles an hour, and they don't need roads. And so if you look at a traditional trip that goes through a city, the average speed along that may be 15 to 20 miles an hour. We can, in some instances, go up to 10 times faster and travel in mostly a straight line, right? So we're not restricted to the circuitous grid on the ground. And this form of transportation we actually think is going to be multimodal. And so your trip obviously won't take off and land in your backyard, but rather operate from a network of skyports. And Roger, you talked about this a little bit earlier. We envision taking off and landing on tops of buildings, on tops of parking garages, areas within the city that are currently underutilized, but because of the lightweight nature of these aircraft and the fact that they can take off and land vertically, we can place those takeoff and landing areas in the most popular places within a city, take off and land vertically, and connect both the first and the last mile with the traditional Uber car. And so you can get from A to B, car to air to car, and still save a good amount of time.
All right, we've got another question here about is the electric propulsion something that the military is looking at?
The answer is yes. And we've seen just within, and I know Uber's had some interaction, I think, with the Army, right? Mm-hmm. But certainly we've seen really all of the military services interested in, for instance, battlefield resupply in urban areas. So the ability to bring, say, water and ammunition into a tight area that maybe a helicopter would not be safe to operate is a big idea. Another thing is agriculture. So, for instance, the German firm Volocopter is looking at using their kind of eVTOL designs that they've built for passenger development. They're looking at using those for spraying fields, so then you don't have to drive a tractor out a long distance and that sort of thing. And you can use it in very difficult terrain, so you can start to develop maybe hillsides for agriculture in a way that you couldn't do if you were relying on tractors. So we're already seeing this happen in China to a great extent.
Awesome. We've got several questions coming in kind of along the same lines, but I like the way this one's worded. Will we be building homes with landing pads on our roofs?
Maybe one day, but what we are, the way that we think about it is building landing pads that can serve as many people as possible. And so what we're doing today is we're using our Uber data. If you take a city like San Francisco or Los Angeles or Dallas, we have pretty good insight into how people are getting around, right? People going between home and work, people going to ball games, people going to the airport, and we're able to get a pretty strong sense of the most valuable places to put these skyports. And so what you'll see in the early days is, and we're already doing this, we're starting to work with real estate developers and cities to figure out the best and most valuable locations to put a skyport. And we'll start with small networks, right? 3 to 5 skyports within a city, located in places where the vast majority of people who are within a few miles should be able to use them. And so that's where we want to start, because what really powers the service is being able to share trips, right? So instead of one person in a large aircraft, we believe that the future looks more like 3 to 4 people inside of an aircraft. That allows everyone to split the cost of traveling from A to B and ultimately makes it as affordable as possible.
All right, and it's funny, we just got a question in asking how many people would fit. So 3 or 4 is what you're looking at?
We think it'll be a pilot plus 4 passengers maximum. And we want to use the power of our software and a lot of the data that we have in-house to make sure the vast majority of those trips are 3 to 4 people.
Okay. So this is a question, and I want to look at today, but then Roger, I'd like you to look backwards a little bit on it. How are we going to make these services affordable for the average person? And then Roger, how did that come about with air travel?
So we have had urban air mobility in the past in this country. So starting after World War II, there was an effort on the part of the U.S. government to subsidize first mail and then passenger service in three U.S. cities, and then also San Francisco. So that was Los Angeles, Chicago, New York had these helicopter airline services. And the problem with them is they never got to the point where the government wasn't paying about half of the cost to operate it. So because they were using these helicopters that had all these kind of expensive components and weren't as efficient, it never quite took off. But by 1967 or so, there were 1.2 million passengers being moved by these urban air services. So it was actually a pretty significant effort. And unfortunately, in the 60s, when there was the Apollo program, the Vietnam War, and all these other priorities, the government stopped funding that, and those services kind of collapsed and went away by the late 1970s. And so we kind of lost that vision of being able to move by air that we had, 40, 50 years ago. So that's kind of where we are. We're trying to bring back an idea that has existed in the past.
And Nikhil, what about Uber? How are you guys handling that?
Well, affordability is tremendously important to us, right? We want to build a service that millions of our riders can use across cities around the world. And the best way to think about it, Marty, is, a helicopter costs about $10 a mile for a passenger today. And an eVTOL, these new aircraft that we're talking about, because they're all electric, because they have a fixed wing like an airplane, automatically cuts off about a third of that cost. So we're looking at between $5 and $6 a passenger mile just with the new aircraft alone. The big cost driver, we think, is putting it onto a platform like Uber, where we can get tens of millions of people around the world to use the technology. And ultimately, if you look at the dynamics for any one single aircraft, it's both being highly utilized, meaning all day long it's going back and forth between these different skyports, and two is they're full the vast majority of the time. And so we want to, as I mentioned, ensure that the skyports and the routes that are being traveled are really popular. Something like Smithsonian to Dulles, or downtown DC to Dulles, or San Francisco to San Jose, where every single time the aircraft flies, it's full. And using both of those levers, we think we can pretty quickly, right, within a few years, get the cost per person on par with an UberX, right? So imagine being able to fly 20 or 30 miles for the same price per mile as an Uber. And we think we can get there pretty quickly. And over time, as you get new technologies like full automation of the aircraft, manufacturing at scale so that these are built more like cars and less like airplanes, we think that cost will go down even further, something close to about 50 cents per passenger mile, which, by the way, happens to be about the same cost as it would be to drive and operate your own car, right? And pay for parking, pay for insurance, pay for maintenance. And ultimately, long term, we think that's really exciting, where you could fly to work instead of drive to work.
All right, we've got a couple of questions here that I think fit well together. So Renee from Myrtle Beach wants to know if you would be flying between skyscrapers or over the top of the skyscrapers. And then also somebody else asked, how high can these types of vehicles fly?
Yeah, so they'll fly at about 1,500 feet above the air and above the ground. And that should clear the vast majority of buildings. What we want to do, and you'll hear Dr. Tom Prevost talk about this in depth tomorrow. So Tom worked at NASA for over 20 years building out a new form of digital air traffic management. And so what we're already starting to do in cities is work with NASA, work with the FAA to think really carefully about the routes that these aircraft will take between skyports. And we'll design those routes, both working within existing VFR corridors that helicopters use today, to think really carefully about routes that, one, can avoid a lot of traffic, and then two, can operate really seamlessly within existing commercial air traffic today. And we'll design those routes to have minimal impact on the community, and also fly safely between A and B.
Awesome. And if you all have questions about that, be sure to tune in tomorrow. We are going to be talking about safety and that infrastructure that goes into all of these new vehicles that we've been talking about today. You all watching online have had some incredible questions. Unfortunately, we're just about out of time today. I do want to remind everybody that you can tune in tomorrow to learn about safety of these future vehicles, as well as the infrastructure that we use with those. On Wednesday, we'll be talking all about the careers in aviation, all kinds of different careers that you can have, everything from videographer to pilot and everything in between. Also, Wednesday, I want to encourage everybody at 10 o'clock Eastern time. We have a very special chat that we're going to do all about animals in aviation. I want you to tune into that. It's going to be a really great chat. You can ask your questions all about animals. And then on Thursday, we'll have Dr. Margaret Weidekamp answering all of your questions about science fiction. And some of the stuff we were talking about today seems very science fiction-y. So I hope that everybody that watched today can tune in. And Nikhil and Roger, thank you both so much for joining us today.
Thanks for having us.
Thank you.
Thanks for watching.